problems and show you how to compute them. If you have that really nice calculator or if you have a not as nice calculator like mine. Okay? So, let's go through some examples. I think today we'll probably have time to work through 2 examples. If the first example's funky, don't worry you guys, just sit tight. I never expect understanding after this one example. We'll also be playing with this more on Monday, so you've got time. Before I start, actually, I will say that over the weekend, it would be totally great if you guys could do 1 through 7 odd in section 8.6. That's 4 questions. It's not a whole lot of homework. Okay? I know that your syllabus says more than that, but that's as far as we're going to get today. All right. So you guys are assigned the odd problems, and therefore I'm going to do the even numbered problems. But I always add an extra little part to it because it's really interesting. So the first one I'm going to look at in 8.6 is number 2. If you don't have your book, don't worry. I will read to you all of the relevant information. Now, the cool thing about when you're dealing with normal distributions is A, you always have to be told that it's normally distributed. That's given. There's no guessing games going on there. Number 2, you will always be given your mean and your standard deviation. So you don't have to worry about computing those in the comments. Okay? So, this first one is factory workers' wages. It says, according to the data released by the Chamber of Commerce of a certain city, the weekly wages of factory workers are normally distributed. So, bam, normally distributed. We got it. We know what types of computations we're going to have to deal with. And furthermore, we're given, it says, with a mean of $720 and a standard deviation of $60. This is all given to you. What we want to do is find a couple probabilities. I'm going to change the numbers a little bit, but let's find the probability that a randomly selected factory worker how about part A makes more than, how about $700? All right. So, we know this is a normal distribution, okay? We know our mean is $720, and our standard deviation is $60. Do you guys agree? First thing I'm going to do is translate this. That I want to find the probability that X is greater than 700. Do you see how I got that? If you don't, ask, please. You with me there? Okay. Now, remember, if you have a nice calculator, at this point, you're good to go with your computations. Because remember, with those nicer calculators, you need to put in your lower, your upper, your mean, and your standard deviation. If I'm interested in the probability that X is greater than 700, do you guys agree my lower is 700? Cool. Now, if I want to know my upper, yes, this goes off to infinity. But what did we put in place? There's no infinity button. What's the standard procedure for us? 10 to the 99th power. What's my mean here? 720. And what's my standard deviation? 60. You guys are scales. My calculator doesn't do this. as we saw before, and as I mentioned to you guys on Wednesday, my calculator can only compute a standard normal situation. Remember, the standard normal means that your mean is 0 and your standard deviation is 1. So, guess what I have to do, and all of you guys who have a calculator just like me have to do? What we have to do is do an extra step. But it's all worthwhile. Okay? What we need to do is we need to convert ourselves over to a standard normal situation. That means that we have a formula we need to use. Yes?
How do we get to the part where we put lower and upper? Like, how do we do it on the calculator?
You remember you hit second distribution or second bars? I'll go through it with my calculator momentarily. I promise, I have it here. But I wanted to go through this part first. All right, this formula will be given to you, okay? Z equals x minus mu over sigma. Remember, your mu is your mean, and your sigma is your standard deviation. You guys remember that from Wednesday? All right, so essentially, what I need to do is find my z value. You see, we want to find the probability that x is greater than 700. I need to find my z-score for that. Remember, your z-score talks about how many standard deviations you are from the mean. Okay? In general, we use x when it's any normal distribution. I use z when it's a standard normal. You don't have to worry about the variables, but I just wanted to explain why I have that. So what I need to do is convert this over to the standard normal using this formula. Okay? How would I do that? Well, my x value is 700. What's my mean? 720. And what's my standard deviation? 60. Do you see how I plugged that in? Now, for those of you guys who found you had a nicer calculator, you can kind of ignore me at this point because you don't have to deal. All right, so 700 minus 720 is negative 20 over 60. You get negative 0.33. That's the extra step that all of us folks with these calculators have to do. Are you guys with me there? Now, if this formula is weird, don't worry about it. We're going to be using it a lot. Okay? So, how would I plug this into my calculator? Well, it's so wild. Whenever I'm in this class, my calculator doesn't work very well. When I'm in my other class, it works great. Give me 1 second here. All right. We seem to be experiencing technical difficulties, right? 1 sec. My calculator's working. Let's see here. Oh, maybe that wasn't in all the way. All right. So you're going to have to just trust me while I play with this a moment. Gosh, I'm sorry. Let me turn that. Oh, there it is. Sweet. I know. All right. What you do is you hit second bar. Hopefully you were here last time, because otherwise you might be confused. And what you're going to get is that district. God, why is this not working? I'm really sorry, you guys. Let me re-plug it in. Huh? I know, or bashing it on a tabletop tends to work for me too. All right. Well, you're going to hit second Okay? No. But thank you. So hit second bars, you go down to normal CDF and hit enter. So what it should look like on your calculator right now is normal, CDF, and then a parenthesis. Well, what do you put in? You put in negative 0.33, comma, 10 to the 99th power. Okay? Notice it's different than if you had a fancier die. If you put that in, you're going to get about 0.63. You guys with the nice calculators, when you put this in, is that what you guys got? Sometimes it's off by a decimal point or so. Really curious. Okay. So, any questions this far? Do you have it with your calculator? Okay, just want to be sure. All right, so let's do another part. Now let's find the probability that a randomly selected factory worker makes between, how about $700 and $750. Our mean and our standard deviation are still exactly the same. Nothing's changing but our x values. All right? So, those of you guys with the nice little calculators, you agree your lower is 700, your upper is 750, and you still have the same mean and standard deviation? All right. So, if you have the nice calculator that when you hit normal CDF, it comes up that way, cool. Now, for those of us who don't have it, do you guys agree that what we're wanting to find is the probability that x is between 700 and 750? Yes? Now, you guys, don't ever forget that you have a very lazy teacher, okay? Normally, if you have to find more z-scores, you probably already have one of them computed. Notice, we already have our z-score for 700 computed, don't we? Okay? I don't like to have to compute too many z-scores. So I already computed that from the previous part. Didn't we already find that z-score? So now, don't we just need to find one more? Yeah. How do we do that? You use that formula, z equals x minus mu over sigma. In this instance, isn't 750 my x value? My mean doesn't change, and neither does my standard deviation. And I claim here you're going to get 1/2. All right. So what would we plug into our calculators? We would do normal CDF. My lower bound is negative 0.33, and my upper bound is 0.5. You guys with me? So let's do the computations and make sure we get the same thing. You should get about 0.32. You okay? Any questions this far? All right, here's something new. But before I do my new, it's still the same problem. We're still dealing with factory workers and their wages and the mean and the standard deviation, all the same. But do you guys agree that essentially what's been happening so far is we have an x value. We're wanting to find a probability, right? For those of us with my style calculator, we also then have to find our z-score. And then we find our probability by using the normal CDF. Do you guys agree? That's what we've been doing? All right, now we're going to actually be given something different. What if now, same question, I want to know the following. What would be the minimum wage a worker would have to make in order to be in the top 10% of all such workers? All right. Do you guys agree I am not being asked to find my probability here? I'm given my area or my probability. Now what I want to do is find the wage, and in this case that's my x value. That corresponds to this. All right, first off, do you agree if you're in the top 10% you're living over here? Yeah. Do you agree if you're in the top 10%, that means 90% are below you? Why do I make that comment? Well, no matter which style calculator you have, your calculator can only deal with the area to the left. All right? So, what we're going to be dealing with now, here in this type of situation, is we're essentially going to be starting with the probability. And then, those of us with my type of calculator, we're going to have a z-score, and then we're going to have to find an x value. Some of you guys will be able to directly go here. People like me, we're going to have to do it like that. Okay? So, how do you do this? Well, if you hit second bars, right beneath your normal CDF is inverse norm. No matter what, you have to put in the area to the left. Okay? Now, those of you with a nice calculator, what's going to come up is it's going to say area, mean, and standard deviation. Do you guys agree if you're in the top 10%, the area to the left is 90%? So you put 0.9. And again, your mean is still 720, and your standard deviation is 60. Okay? Those of you guys with the sweet calculator, have fun. Those of you guys with the calculator like me, you're going to hit inverse norm 0.9. You should get 1.28. Did you guys get 1.28? Those of you guys with my style calculator. Okay? Those of you guys with a nice calculator, you already know the answer. Who here has my style? You do. Did you get 1.28? Cool. All right. Clearly, $1.28 is not the weekly wage that's going to place you in the top 10%. Okay? What we have is our z-score that corresponds with the standard normal. So you know what we've got to do? We've got to do an extra step. We have to find, see, we went from here to here. Now we have to find that x value. You use the same formula, but now we're looking for x. Our z is 1.28. We're looking for x, and our mean is still 720, and our standard deviation is still 60. You guys, I know this sounds like a lot, but I swear, once we do a few examples, you're going to be like, boring. Seriously, if you're not already. How can you feel that way in a math class, right? Okay, so algebraically, how would you solve this? Well, you look at this and you say, ew, we have a fraction. Let's get rid of our denominator, right? right? Fractions are like kids. Whatever you do to one, you got to do to the other. So, do you agree if I multiply my right side by 60, you get x minus 720? And on our left side, you take 60 times 1.28, and you're going to get 76.8. Can we get x? Oh, yeah. How do you get x all by its lonesome? You add 720 to both sides. So do you agree we're going to get $796.80? And those of you guys with the sweet little calculators, within rounding error, is that what you guys got? You got 89 cents. Yeah, that's within the rounding error. Isn't that cool? So if somebody of this factory says, yo, I make $796.80 a week, we could say, well, geez, you place in the top 10% of all of us in terms of your wages. All right, so let's do another example. Let's quit talking about money. Same types of things we're going to do, okay? But since I threw in a greater than in the previous example, we'll do a less than in this one, okay? And then we'll do more on Monday. All right, so let's look at number 4 in your book. So this one says, on average, ooh, what are you all thinking with average? What's that? You're mean, good job. On average, a student takes dictation at a speed of 100 words per minute, midway through an advanced court reporting course at the American Institute of Court Reporting. We're already given our mean is 100. You with me there? Assuming that the dictation speeds of the students are normally distributed with a standard deviation of 20 words per minute, we want to find some probabilities. You with me this far? All right, so we're given that it's normally distributed, we were given our average, and we were given our standard deviation. So let's find the probability a randomly selected still in the previous question. A randomly selected student takes dictation at a speed of, how about less than 110 words per minute? All right, first thing I'm going to do is I'm going to put this in inequality form because it's just the way my brain works. Do you agree? We're wanting to find the probability that x is less than 110. You all with me here? Okay, if you have a question, you guys, please ask. You're going to be tested on this special week from today. All right, now, those of you guys with the quick, nice calculators, you just need to figure out what's your lower, upper, mean, and standard deviation. Now, if you're interested in the probability that x is less than 110, we don't have a negative infinity button on our calculator. So what is the standard operating procedure here to put? Negative 10 to the 99. That's why we went through all of that stuff on Wednesday. Now, what's your upper bound? 110, and your mean is 100, and your standard deviation is 20. Why is your lower 0? Yeah, technically, you could say 0, but we, to be within the same rounding error as us, we just tend to use negative 10 to the 99. Truthfully, it would be fine to say negative 100. But you're absolutely right. The question was, why can't you just put a 0 in here? Because it is the case that your not going to type negative words per minute unless you're seeing make typos left and right. We just follow these operating procedures all of the time. But logically, you're bang on. Okay? Those of you guys with my type of calculator, I need to find my corresponding z value. Okay? So, I say z equals x. Isn't my x here 110? Minus my mean, which is 100, over my standard deviation, which is 20. You with me here? Do you see how this is the same as what we just did? What do you get? 0.5. So now what we put in is normal CDF. Again, to show that it's less than, we too have to deal with that negative 10 to the 99. And then we put in 0.5. You with me here? Yeah? So negative 10 to the 99th comma, 0.5, and we're going to get about 0.69. Any questions on this part? Are you guys following me? Okay. Does anyone have any questions this far? Sweet. All right. So let's do part B and then part C. So now let's find the probability that a randomly selected student takes dictation at a speed between 110 and 150 words per minute. And then we're going to do one of those inverse norm guys. All right. Do you guys agree that I'm finding the probability that x is between 110 and 150? Okay? Again, those of you guys with that nice calculator, 110 is your lower and 150 is your upper. For those of you folks in the same boat with me, guess what we have to do? Z-scores. But again, didn't we already find our z-score for one of these guys? Yeah, who do we have our z-score for? 110. We already found that to be 0.5. You with me there? So, what do we now need to do? We need to find our z-score corresponding to 150, don't we? So z is 150 minus 100 over 20. You with me there? So you get 50 over 20, which is 2.5. Everyone okay? All right. So what we will put in then is normal CDF, and I have both my endpoints, 0.5 comma 2.5. So let's see what we get. 0.5 comma 2.5, and we get about 30%. Any questions on this? Why is it what? 0.5. 0.5? Oh, because didn't we need to find our z-score for 110? But we did that up here. Didn't we have to do that for part A already? You can do it again if you want to, but you might as well use what you've already done. And a big hint is I tend to do that because I don't want to waste your time on a test computing tons and tons of z-scores.
So when you have to find this mean, you have to find the mean first.
Yes, you do. That's a great question, thank you. Are there other questions? Okay. Part C. What is the minimum 97th percentile? And that is a question. How could I have worded this to be like our last example? In other words, 97th percentile is equivalent to what? The top what? The top 3%. Saying these two things are the same. All right? You all with me there? No matter what, though, you always put your area to the left. Now, what's nice about this is when you're actually given the percentile, you already have the area to the left. If I told you top 3%, you'd have to do that extra step, right? 100 minus 3 is 97. Not like it's too bad. So, what I'm going to type into my calculator is inverse norm 0.97. And I get 1.88. Okay? You guys who have my type of calculator, you with me this far? Okay, clearly it's not 1.88 words per minute. That's more like my speed. Okay? So, what we have found is our z-score. We now need to use that lovely little formula in order to find our corresponding x value. Are you ready to do that? Cool, me too. What is my z? 1.88 equals x minus, what's my mean? 100. And my standard deviation is 20. How do we solve this, you guys? All right, what you do is you take 20 times both sides to get rid of your denominator. On my right side, I get x minus 100. On my left side, I'm going to get 37.6. So do you agree it's 137.6 words per minute? Are there any questions on this? What do you think of this stuff? Hard, easy? Yes?
So on the calculator, standard deviation.
Yes.
And I think it's
Oh, it's the same standard deviation. So if this question was asked with the other calculator, when you hit inverse norm, the first thing it'll say is area. And you put 0.97, correct? The next thing okay, it asks the mean and then the which was 100 and the standard deviation, which is 20. Your mean and your standard deviation won't change.
Yeah, it was like
Are there any questions, you guys? It is worth it to get a nice calculator, I suppose, but this one was free for me, so I take what I can get.